Welcome to this lesson on determining the inverse function for logarithmic and exponential functions. So first, let's recall some ideas about functions. Listen to the description of the function based on the order of operations, then write what the function would be. Here's the description. The output of a function, f of x, is determined by first multiplying the input x by 7 and then adding 18. Finally, the result is divided by 2. So how could you write that expression using function notation? Consider your order of operations. Here's what you would have found. Notice multiplying by 7 first, then adding 18 and dividing the whole result by 2. Now let's try a different exercise. What might the inverse function sound like or look like? The output of a function, f of x, is determined by first multiplying the input x by 7, then adding 18, finally the result is divided by 2. So that was the description again of our original function. But what might the inverse function look like or sound like with words? Some ideas you may have to consider are, well, the inverse of each of these operations might be multiplying by 7 would indicate dividing by 7, adding 18 would indicate subtracting 18, and finally, dividing by 2 would indicate the opposite of multiplying by 2. But what would the order of these look like and what would the function look like? That's where we're going to start. So here's our original function and we want to find the inverse of it. In Algebra 2, you may have used different methods. We're going to focus on the idea of do and undo charts, or original function and inverse function charts. So first, we're always going to consider x, the input, and what operations are happening in what order. PEMDAS will help us with this. So here's our chart that we're going to use. Consider what original function is happening first to x. Think of PEMDAS again. First, we're going to multiply by 7, then we're going to add 18 and divide by 2 at the end. That was the order in the description and the order based off of the operations shown. Now we can consider the inverse of each of these. Opposite of dividing by 2 would be multiply by 2, then subtract 18, and then divide by 7. This inverse side of the chart allows us to make our inverse function. However, it's really important to remember we have to build our function from the bottom up. So let's start with our inverse function. Our inverse function always must have an x or an input. Now what are we going to do to that input? Well, starting from the bottom, we're first going to multiply it by 2. Then we're going to subtract 18 from the result. And then we're going to divide everything by 7. This would be our inverse function. Notice how we started with the input of x and worked from the bottom of our chart up. So now it's your turn. Consider this function. What would be the first operation of this function? And then try to consider what the inverse operation would be. So the operations you see are subtracting 3, dividing by 10, and doing the square root. The square root is actually like an exponent, so that would be your first operation. But what's the opposite of square root? Keep in mind that opposite of square root is squaring. Now try to actually find the inverse. Here's what you could have found. We start with our input of x, and what we're going to do first is the square root, then subtract 3, and then divide everything by 10. So for our inverse, starting from the bottom up, the opposite would be multiply by 10, add 3, and again, like we mentioned, the opposite of square root is to square. So now, when we make our inverse function, we start with an input of x. The first thing we're going to do is multiply it by 10, then add 3, and we actually have to square the whole result. As you work from the bottom up, you must include everything that was there before. So now let's take a look at this original function. Consider the operations you see and what the inverse would be. We notice we multiply by 6, we subtract by 5, and we also have a log base 3. Think of our former lesson. What's the inverse of log base 3? So take a moment and try to number the steps of what would be happening based on the order of operations. Here's what you could have thought. The order of operations tells us to do parentheses and exponents first. The log base 3 is actually tied to an exponent, so the first thing that we would do is take the log base 3 first. Then we would multiply by 6, and then we would subtract 5. So now let's actually find the inverse function. So first we have our log base 3. We're going to multiply by 6, subtract 5. Now we need our inverse operations. Add 5, divide by 6, and remember from a previous lesson, the opposite or inverse of log base 3 is to have a base of 3 for an exponential. Now we can build our function, from the bottom up of course. So starting with x, the first thing we're going to do to the x is add 5 to it. Then the next thing we're going to do is divide everything we already have by 6. And we're going to raise 3 to that whole power. So be careful whenever you're working with logs and exponentials that it's very clear that your 3 looks like a base and everything else is an exponent. Now consider this one. Number the steps for these order of operations. Here's what you may have found. Be very careful with the exponent and the adding 1. We do want to do our exponential using base e. However, notice the x plus 1 could actually be written in parentheses because the plus 1 is part of it. So we would add 1 first, then use the exponent of e and divide by 7. So now we can start. And the inverse of all of these operations, multiply by 7. The opposite of a base of e would be a log with an e, or simply the shortcut ln. Whenever you see e, ln would be its partner. Now we can build our function from the bottom up. First we'll start with an x, and we're going to multiply by 7. Then we're going to take the ln of that and subtract 1. So the do and undo charts is just one method for finding the inverse function. But there's also another way you may have seen. This is the method that Delta Math will show in its solutions for your homework. It may explain that you can switch x and y. So f of x is y, and x, your input, is just x. So notice how they were switched. And then you're going to solve for y instead. So this is just another method that you may come across. Let's try another example. Try to find the inverse function of this function here. Here's the solution that you should have found. Notice that the minus 2 is actually the first operation because of the parentheses, then your log base 4 because of the exponent, and then divide by 5. So let's consider one more function with a few more steps. Number these steps according to the order of operations. Here's what you should have found. First, we're going to add 2 to the x, then divide by 8, then raise 7 to a power, and multiply by 5 at the end. So now, there's our original operations you already decided. What would the inverse function be based upon that? Pause the video and try. Hopefully it shows that option B would be the correct inverse function. Starting from the bottom of the chart and working up, first you would divide by 5, then do log base 7 of that before multiplying by 8 and subtracting 2. Notice how all of these choices are very similar, however the use of parentheses and what's included with a log is a big difference. So be careful with how you're writing your final inverse function.